UVC for wastewater and graywater disinfection. What is wastewater? Put simply, wastewater is used water. It is water that has been used in the home, in a business, or as part of an industrial process. It may include the following: human waste, food scraps, oils, soaps, and chemicals. In residential homes, this may include water from sinks, showers, bathtubs, toilets, washing machines, and dishwashers. Industrial wastewater originates from manufacturing, mining, agricultural production, and chemical cleanup. While wastewater may include feces, urine, and other harmful contaminants, there is a classification of water with a lower contamination level called gray water. What is gray water? Gray water is defined as household wastewater, typically from a sink or bath, that does not contain the level of fecal contaminants present in wastewater from toilets, which is also called sewage or black water. It is typically comprised of fats, oils, grease, and other organic matter. It may also contain small traces of human waste that may have washed off the body or off clothes, or been tainted by sewage due to faulty plumbing connections. For this reason, it likely contains pathogens which require disinfection. Quality of this water can deteriorate even further if stored in a warm place, as that facilitates the growth of pathogenic bacteria from the particles of organic matter contained in it. Gray water may be used for crop irrigation or replenishing toilet water, but it is certainly not safe for drinking. The reuse of gray water for proper purposes is actually very helpful to urban water systems as a means of reducing the demand for fresh water. Global population and industry have put pressure on available clean water sources. The proper treatment and reuse of gray water and wastewater is essential in alleviating this water stress. Maintaining clean natural waters. Nature on its own can cope with small amounts of water waste, but for the billions of gallons of sewage we generate every single day, it is imperative that we have water treatment facilities to reduce the pollutants in wastewater to a level the environment can handle. Treated wastewater that is returned to the environment is called effluent. Keeping our water supply clean is essential both for the cleanliness of our environment and for our own health. Our planet's wildlife depends on clean water in their respective habitats to simply survive. Animals that live on land and in the air depend on fresh water sources to stay hydrated and to bathe. The Earth's oceans, lakes, rivers, and streams teem with marine life that require unpolluted water in the same way that we depend on fresh air. As man relies on the animal kingdom for food, clothing, and recreational activities, it is certainly in our best interest to maintain these pristine natural waterways to the best of our ability. When wastewater is not properly treated, harmful contaminants seep their way into our oceans and lakes. Some of these substances are decaying organic matter, miscellaneous debris, ammonia and chlorine, bacteria and viruses, metals, and pharmaceutical products. The result of these pollutants being introduced into our natural waters can be deadly. Oxygen becomes depleted, chemical concentrations become toxic, and entire populations of aquatic life can become contaminated. This has disastrous ramifications for the delicate balance of nature we depend on for our very existence. Furthermore, it has been reported that some water companies have come under scrutiny in recent years for illegally dumping sewage in rivers and beaches. Wastewater discharge regulations have evolved in an effort to thwart this practice. Unexpected sources of contaminants. Storm runoff has been observed as a source of wastewater infecting our natural water sources. You might think that rain flowing down a road is relatively clean, but consider all the harmful substances, dirts, oils, chemicals, etc., it is bringing with it as gravity carries it down into lakes and rivers from streets, parking lots, and rooftops. Aside from human sources that comprise wastewater, there are many harmful synthetic properties floating around in there as well. Healthcare products such as toothpaste, face wash, and shower gel all contain microbeads, plastic fragments smaller than 5 millimeters. When clothes made of synthetic materials such as nylon are washed, microfibers, sometimes smaller than 10 microns, enter the wastewater stream. That may seem small, but these microscopic particles combine to have tremendous negative impacts to our ecosystem. Salt and soapy residues as well can be extremely toxic to microbial and plant life. Treating gray water and wastewater. Because of the high level of contaminants contained in toilet water, municipal areas provide a sewage system where this black water is directed underground to a sewage plant for treatment. There, it undergoes a multi-step purification process: removal of large objects, sludge removal, aeration, disinfection, and release back into waterways. These 5 steps of treatment actually mimic how natural wetlands purify water. Gray water, on the other hand, may be treated at the household or building level in a number of ways. Biological systems, constructed wetlands or living walls, membrane bioreactors, bacteria and air combine to oxidize pollutants, sand and lava filtration systems, and UV disinfection. Germicidal UV disinfection of wastewater. The final stage in the cleaning disinfection process of wastewater should be ultraviolet disinfection. While regular filtration methods may remove the larger substances and minerals in the water, many microorganisms will surely survive the process. At this stage, when they are exposed to ultraviolet light at a frequency of 254 nanometers over a determined period of time, calculated based on the type of microorganism present, damage will occur to them at the molecular level, causing their reproductive process to falter and ultimately eliminating their existence. Germicidal ultraviolet treatment is both effective and safe. Atlantic Ultraviolet Corporation manufactures numerous models to provide this germicidal treatment based on the specific needs of the customer. Please refer to the descriptions which follow to learn more. UV disinfection is effective at inactivating most viruses, spores, and cysts. It is a physical process rather than a chemical disinfectant, which eliminates the need to generate, handle, transport, or store toxic, hazardous, or corrosive chemicals. There is no residual effect that can be harmful to humans or aquatic life. Megatron UV water disinfection, 90 to 450 gallons per minute. The Megatron consists of pressure vessel chambers containing multiple germicidal ultraviolet lamps, making each model a completely self-contained disinfection system. Multiple chambers can be combined to handle larger flows. The most featured of all of our water purifiers, the Megatron is particularly suited to large-scale disinfection of industrial and municipal water and wastewater applications. Available in automatic wiper or manual wiper configurations. Sanitron UV water purifiers, 3 to 416 gallons per minute. The Sanitron series of models is of exceptional value. These water purifiers were designed to conform to U.S. public health guidelines criteria for the acceptability of an ultraviolet unit. Each model is well featured and can utilize a number of different optional accessories, such as an ultraviolet monitor or similar device for a more in-depth knowledge of the water purifier's operation. Besides wastewater applications such as process facilities and home water wells, applications also include restaurants, schools, mobile homes, swimming pools, fish ponds, hospitals, laboratories, resorts, hotels, medical facilities, and more. Sanitron models S37C, S50C, and S2400C are NSF ANSI 61 and 372 certified. Atlantic Ultraviolet Corporation. Contact us today.